Good morning, all of you. Welcome to Sri Jayendra Rank Zone. In the last session, we have discussed the concepts, that is periodic properties of elements. So this chapter explanation is finished, that is periodic classification of elements chapter explanation is finished till the last session. Now we are doing questions on this chapter. So in this session, we will discuss only the questions, some important models based on periodic classification. So I'm writing here questions on periodic classification. So question number 1. So these questions comprise of previous Neet Iit-Jee means, and not only that, some important models which I felt it is important for you. So if you do this type of questions, is more than enough for periodic for this chapter. So question number 1. The elements X, Y, Z and Z. The elements X, Y, X comma Y, Y, Z and J have the indicated electronic configurations starting with the innermost shell. Indicated electronic configurations. Full stop. The most metallic element is So they are given 4 elements X, Y, Z and J. The configurations of those elements are as follows. You can see the configurations now. X is equal to 2, 8, 3. Y is equal to 2, 8, 8. And Z is equal to 2, 8, 8, 1. They are given orbital configuration, if you can remember, KLMN. And D is equal to, that is J is equal to 2, 8, 8, 7. J. So 2, 8, 8, 7. Now, most metallic elements in this. First option X. Second option Y. Third option Z. So first option, answer. No, first option, I'm giving options to you now. First option X. Second option Y. Third option Z. Fourth option J. So based on this concept, if you see this concept, elements X, Y, Z, it has how many valence electrons? If you see only valence shell, so X is equal to valence shell 3, because valence shell, you underline here valency, the value of X valence shell it is 3, and for Y it is 8 completely filled, and for Z it is 1, and for J it is 7. So if an element has 1 electron in the valence shell, its valence is 1. 2 electrons, its valence is 2. So 1 electron means definitely it should belong to first group. And already we know first group are strong first group are strong metals. So first group elements. So Z is the answer. I hope it is clear now. So Z is the answer. Why? Because Z is having most metallic in nature, because its configuration is 2, 8, 8, 1. So valence electron configuration is 1. And the remaining for X it is 3, and for Y it is 0, that is inert gases. Inert gases are not metals. And for J it is halogens, because it has 7 valence electrons, that is 7th group elements. So 3 and 7. 3 and 7 and 1. So in between 3, 7 and 1, 1 is most metallic, because if an element has 1 electron in the valence shell, definitely it belongs to first group elements. And already we know first group elements are most metallic in nature. So I hope it is clear now. This is the question 1. Now question number 2. Actually, slide so. తీసేయి నువ్వు అన్ని పిచ్చి పిచ్చి అన్ని స్లైడ్స్ యాడ్ చేయి. Question number 2. We have to add that +1 +2. No? Next question. The most non-metallic element among the following is. 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 Among the following is. First option, beryllium. First option, BE, that is beryllium. Second option, boron. Third option, magnesium. And fourth option, aluminium. So it is. So first is beryllium, next is boron, next is magnesium, next is aluminium. So as we go down the group, the metallic character increases. For beryllium, magnesium belongs to same group, and boron, aluminium belongs to same group. So within beryllium and magnesium, beryllium is least non-metallic, least metallic, so it is non-metallic. But and here second group we have boron and magnesium, boron and aluminium, third group. As we move from left to right, the metallic character decreases, non-metallic character increases. So answer is B. B is answer because it is non-metallic element in the following elements. Next question. That question. Cerium 58. CE 58. Next question. CE 58 is a member of. Option 1, S block elements. Option 1, S block. Member of S block. Option B, P block. Option C, D block. And option D, F block. So answer is F block. Because already we know cerium is lanthanide. So lanthanides and actinides are F block elements. So cerium is lanthanide. So lanthanides and actinides are F block elements. Next question. Next question. The screening effect of d electron is. Next question I'm writing on the board. The screening effect of d electron is. The screening effect of d electrons is. Of d electrons is. First option, much less than s electrons. Much less than s electrons. Second option, greater than s electrons. Third option, equal to s electrons. And fourth option, equal to p electrons. Fourth option, equal to p electrons. So here the question they have given. The screening effect of d electrons is much less than s electrons, greater than s electrons, equal to s electrons, equal to p electrons. So what is screening effect? As we discussed already in the session, it is nothing but the effect, the screening. The inner electrons will shield outer electrons. So d electrons, the screening effect is less when compared to s and p. So it follows the order. The screening effect follows the order. I'm writing the answer here. The screening effect follows the order. 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 S is greater than P is greater than D is greater than F. S greater than P greater than D greater than F. So answer is first option. It is much less than S electrons. I hope this is clear. This order is also important. You can remember this order. That is the additional material I have given. Next question. Next question. The maximum number of valence electrons. The maximum number of valence electrons. The maximum number of valence electrons possible for atoms in second period of the periodic table is possible for the second period of periodic table is second period of periodic table is periodic table is first option 18, second option 10, third option 8, and fourth option 2. So you know first period is the shortest period and second and third periods are short periods and fourth, fifth are long periods and sixth and seventh are largest periods. So already we know in first period we have only 2 elements, second period we have 8 elements, third and fourth we have third period we have, fourth period we have 18 elements, fifth and sixth period 32 elements, sixth period we have 32 elements, seventh period is incomplete. So they are asking here the maximum number of valency electrons possible for the second period of periodic table is 8 because it contains only 8. So answer is 8. Next question. If a certain element has atomic number 19, if a certain element has atomic number 19, comma, the element is. So they are given about the nature of the element. Very simple question, but first option, an inert gas. An inert gas. Second option, a metal with valency 1. A metal with valency 1. Third option, a non-metal with valency 3. A non-metal with valency 3. Fourth option, a metal with valency 3. with valency 3. So if you see here, they are asking atomic number 19. Atomic number 19 means it should be first for this type of questions you have to write the configuration. So if you write the configuration K2, K2, L8, M8, M8, N1. So definitely as it has valence electron, because if you want to know the valency, you have to write the configuration, orbit configuration or orbital configuration. Anything is possible. So even if you can write electron configuration, so valency is 1 means it should be a metal, as it is valency is metal and metal with valency 1. So answer is second option. So in this way you have to answer the question. Next question. Next question. The ionic radius. The ionic radii of Li plus, comma, Be plus 2, comma, B plus 3 follows the order. So this type of question is very important. So they will give the ionic radii of 3 elements and they ask us to find the order. So first option, Be plus 2 greater than B plus 3. First option I am writing Be plus 2 greater than B plus 3 greater than Li plus. Second option, Li plus greater than B plus 3 greater than Be plus 2. Third option, B plus 3 greater than Be plus 2 greater than Li plus. Fourth option, Li plus greater than Be plus 2 greater than B plus 3. So if you see here, the ionic radius of lithium plus means already lithium atomic number is 3, it has lost 1 electron. So it has lost 1 electron, then only it becomes Li plus. So lithium plus, Li plus, next Be plus 2 also it is losing 2 electrons, and B plus 3 also it is losing 3 electrons. So these are all nothing but isoelectronic species because they are having similar electronics, same number of electrons. So these are called isoelectronic species. These are called isoelectronic. As these are called isoelectronic species because they are having only 2 electrons. All of them are having only 2 electrons because same number of electrons. And if you see the ionic radius, what happens to ionic radius? For lithium configuration, if you take the consideration 1s2, 2s1, and for beryllium, it is 1s2, 2s2. For boron, it is 1s2, 2s2, 2p1 because atomic number of boron is 5. So the configuration is 5. So for boron, you are getting 2p1 also. And for beryllium, you are getting 2s. And for lithium, you are getting 1s. So automatically, the answer is lithium plus greater than beryllium plus 2 greater than boron plus 3. So answer is fourth option. Answer is fourth option, that is Li plus greater than Be plus 2 greater than B plus 3. So I hope it is clear. So for isoelectronic species, the group number should be less, having more atomic ionic radius. Next question. Which of the following statements is incorrect? So the following statements is incorrect. First option, the second ionization energy. Adding here the second ionization energy, I dot E of sulfur is greater than that of chlorine. Of sulfur is greater than that of chlorine. Writing in short form. Second option, the third ionization energy of phosphorus. The third ionization energy of phosphorus is greater than that of aluminium. Third option, the first ionization energy of aluminium. The first ionization energy of aluminium is same as that of gallium, is equal to first ionization energy of gallium, Ga. Fourth option, the second ionization energy of boron, second ionization energy of B is greater than that of carbon. So now coming to these questions, how to solve. So they are asking second ionization energy. What is second ionization energy? If you remove one electron from the valence shell, it is called first ionization energy. Similarly, if you remove, what is ionization energy? The amount of energy required to remove. The amount of energy required to remove an electron from neutral gaseous atom is called ionization energy. So if you remove first electron, means if the element has more than 3 or 4 electrons in the valence shell, so one by one we will remove. So if you remove one electron, it is called first ionization energy. And if you remove 2 electrons, it is called second ionization energy, third electron, third ionization energy, and so on. So always, if you see, first ionization energy is lesser than second ionization energy, because second ionization energy is always bigger than first ionization energy, because the second electron, the valence electron, is a little bit close to nucleus when compared to the outermost electron. So definitely, if it is close under nuclear attraction, if it is under nuclear attraction, we can say second ionization energy is greater than. Now they are asking us to compare between sulfur and chlorine. And first option, if you verify, second ionization energy, the statement is incorrect, they are asking. So second ionization energy of sulfur and chlorine. If you see the ionization energy of sulfur, sulfur belongs to 16th group and chlorine belongs to 17th group. As we move from left to right, the ionization energy decreases or increases. The ionization energy increases because the same electron is adding into the same shell. So for sulfur, atomic number 16 and chlorine atomic number is 17. So second ionization energy of sulfur is greater than chlorine is the incorrect statement, because the second ionization energy of sulfur should be lesser than chlorine, because chlorine is having more ionization energy than sulfur. Because as we move from left to right, the ionization energy decreases because the electrons are adding into the same shell, and sulfur and chlorine belongs to same period. As sulfur and chlorine belongs to same period, so second ionization energy of sulfur is greater than chlorine is the incorrect statement. So answer is first option. So first option is correct. So there is no need of saying second or third option. So answer is first option. So remaining, if you verify, they are correct only. You can just see. Next question. Lanthanides are called. Lanthanides are called. First option, rare earths, RAREERTH, rare earths. Second option, alkali metals. Second option, alkali metals. Third option, alkaline earth metals. Alkaline earth metals. And fourth option, nicogens. P silent here. Alkaline earth metals. Fourth option, nicogens. PNICOGENS. So lanthanides and actinides, they are called as F-block elements, and they are also called as rare earths. So answer is first option, because we know alkali metals are first group metals, alkaline earth metals are second group, and nicogens are nitrogen group. It is 15th group. So only lanthanides are called rare earths. Next, because they will not appear in the earth easily, so on the earth's crust, that's why they are called as rare earths. Next, very very important question here now. If the ionic radii of K plus if the ionic radii of K plus and F minus are about 1.34 angstroms each, are about 1.34 angstroms each, then the expected values then the expected values of atomic radii of fluorine and potassium would be, sorry, atomic radii of K and F should be K and F. Atomic radii of K, that is potassium, and fluorine F should be respectively. First option 1.34 and 1.34 angstroms. First option 1.34 and 1.34 angstroms. Second option 2.31 and 0.64 angstroms. 2.31 and 0.61 angstroms. 64 angstroms. Third option 0.64 and 2.31 angstroms. 0.64 angstroms, comma 2.31 angstroms. And fourth option 2.31 and 1.34 angstroms. So we already know the atomic radii is always greater than the ionic radii because the distance between center of nucleus to outermost orbit is called atomic radii. Whereas ionic radii means the distance between the center of nucleus to the outermost electron of an ion. Here ion means already one electron is lost. So it has greater nuclear attraction. And F minus is anion and K plus is cation. So definitely the answer will be F minus is bigger than K plus. So answer will be third option, that is 0.64 and 2.31 angstroms. Because cation and anion ratio, if you take, that is only matching. Third option, just is simple common sense here. Anion, that is F minus, is greater than cation. So K plus and F minus, and K and F should be so 0.64 angstroms and 2.31 angstroms. That is for only ionic radii. But they are asking here atomic radii of potassium and fluorine. So potassium and fluorine will be, so answer is second option. It is not third option. If you take only ionic radii, this is the third option. But second option is 2.31 angstroms and 0. Because potassium is atomic number is 19. Second option is the right answer because potassium atomic number is 19 and fluorine atomic number is only 9. So it has 3 shells and it has only 2 shells, fluorine. So K2, Kl shells, and for potassium it has K, L, and M shell also. So automatically the atomic radius is bigger for potassium than fluorine. So the answer is second option, that is 2.31 and 0.64 angstroms. So even you can take fourth option also, but fourth option is 1.34 ionic radius. So since they have given fourth option also, if you see fourth option, D option, that is 2.31 and 1.34. These are also matching. Anyway, one will be bigger, another will be smaller, because in other case it is equal and less. But in the only possibility option is B and D. But why D's option is not correct? Because already has given F minus ionic radius 1.34. If ionic radius is 1.34, automatically the atomic radius should be less than ionic radius in case of anions. You just note down the statement. In case of anions, the ionic radii is bigger than atomic radii. In case of anions, the ionic radii is greater than atomic radii. So definitely it should be less than, because they have given already ionic radii of F minus is given as 1.34. Definitely that should be lesser. So the answer is 2.31 and 0.6. So there is no formula for this, nothing. Just it is only a conceptual based question. And in this concept, we can say the as we go down the group, or as we move from left to right, because fluorine is second period and potassium is third period. So third period is having more atomic radius than second period elements, even though it is cation and anion. And they have already given F plus and F minus and K plus ionic radius 1.34 angstroms each. So definitely for anions, the in case of anions, the ionic radius should be greater than atomic radii. So the option only matching is second option. In fourth option also we can say little bit, but second option is correct because the atomic radius, the ionic radii is always greater than atomic radius. So it cannot be equal. So that's why second option. I hope this is clear. Next question. The species F minus, the species F minus, Ne, comma, Ne, and Na plus are isoelectronic, Which is the correct order? Now the question is, which is the correct order? Which is the correct order when they are arranged in the order of, which is the correct order when they are arranged in the order of, when they are arranged in the order of decreasing size. Decreasing size means decreasing order of size. The order of decreasing size. So that is the largest first and the lowest last. Decreasing size. First option, F minus, F minus greater than N, Ne greater than Na plus. Second option, Ne greater than Na plus F minus. Third option, Na plus greater than F greater than Ne. F minus greater than Ne. Fourth option, F minus greater than Na plus greater than Ne. So this is very simple question and important also. So within the isoelectronic species means which contains same number of electrons. So automatically the anion is bigger in size than the neutral than the cation, because if you see F minus is bigger in size when compared to neon because of its anionic nature, because F minus means electron is gained. In F minus we have only 10 electrons and 9 protons, whereas neon we have 10 protons, 10 electrons, whereas sodium we have 10 protons, 9 electrons, sorry, 11 protons and 9 electrons. So naturally the nuclear attraction is more for sodium plus, then neon, then F minus. So if the nuclear attraction is more for Na plus, so for any element, for any species, its size is less. So automatically the answer is first option, that is F minus, first option, F minus, Ne and Na plus. So I hope this is clear. Anion is bigger than neutral than cation within the same isoelectronic species because they are belonging to same period. I hope this is clear. Next question. Next question. The screening effect of inner electrons. The screening effect of inner electrons of the nucleus. The screening effect of inner electrons of the nucleus causes inner electrons of the nucleus causes first option, a decrease in ionization potential, a decrease in IP, in ionization potential, a decrease in ionization potential. Second one, an increase in the ionization potential. An increase in the ionization potential. Third one, no effect on ionization potential. Fourth one, none of this. So it is very simple question. The screening effect of inner electrons. If the screening effect of the inner electrons is more, so automatically it cannot shield outer. It can successfully shield the outer electrons, so that outer electrons will not come into attraction of the nucleus. So due to which, what happens if there is no attraction of outer electrons to the nucleus? It's very easy to remove. Hence, there is a decrease in ionization potential takes place. So the screening effect of inner electrons of the nucleus causes decrease in ionization potential. I hope it is clear. So this is the answer. Next question. Next model is also very important. So we are doing only randomly all the important models. Anyway, last worksheet will be sent to you. You have to do all those worksheets compulsory, so that easily you can get grip on this chapter, so that easily you can solve all the questions. Once you see the slides and if you listen to the video lecture carefully, anyway you can do it. Next question. An element X which occurs in the first short period. Which occurs in the first short period. This very conceptual typical question. Which occurs in the first short period has the configuration S2P1. They have not mentioned the principal quantum number, just they have given the configuration S2P1. S2P1. S2 2 on the top and P1. S2P1 configuration. What is the formula of the acid-base character of its oxide? What is the formula? What is the formula? And acid-base character and acid-base character of its oxide. First option, XO3. Second option, XO3. I'm sorry, first option XO3 comma basic. XO3 comma basic. Second option, XO3 comma acidic. Third option, X2O3 acidic. And fourth option, X2O3 basic. So it's a very simple question. So you should know the element X has how many valence electrons? It has only 3 valence electrons. So the valency of X is 3. Because it has 3 valence electrons, X valency is equal to valency of X 3. And oxygen valency already know it is 2. Valency of oxygen is 2. Because we know oxygen valency is 2. So by crisscross method, the formula of the compound is X2O3. Crisscross method, the formula of the compound is X2O3. Now the question is whether it is acidic or basic, because X2O3 they have given both acidic as well as basic. Now if you see S2P1, it belongs to third period because it belongs to 1s2 2s2P1. So it has 3 valence electrons. So it belongs to third group also, you can say 13th group. So 13th group oxides. The oxides of 13th group are acidic in nature. The oxides of 13th group are acidic in nature. So answer is X2O3. It is nothing but as it has 3 valence electrons. Mostly the oxides of acidic in nature because they are less metallic. So metallic oxides are basic and non-metallic oxides are acidic. So it is probably a non-metal. So because it is 13th group, so it is acidic in nature. So answer is X2O3 is acidic in nature. Next question. An element has, this question is most important model. An element has successive ionization enthalpies, successive ionization enthalpies, successive ionization enthalpies or ionization energies as 940, that is first ionization energy, 940, 940 bracket first ionization energy, first I, comma 2080, comma 3090, comma 2080, comma 3090, 4140, comma 7130, sorry 7030, comma 7030, comma 7870, 7870, comma 16,000, 16,000 and 19,500 kilojoules per mole respective. 19,500 kilojoules per mole. To which group? To which group of the periodic table? To which group of the periodic table does this element belong to? Of the periodic table, does this element belong to? This belong to. Belong to. Belong. Question mark. First option, 14th. Second option, 15. Third option, 16. Fourth option, 17. 16, 17 question answer. So it is very typical question. An element has successive ionization energies as 940 first ionization energy, second ionization energy is 2080, third is 3090, fourth is 4140, fifth is 7030, sixth is 7870, sixth is 16,000, and seventh is 19,500 kilojoules per mole. To which group of the periodic table does this element belongs to? Generally, if they are given this type of questions, so if an element has 5 or 6 electrons or 7 electrons, we can take all the 7 electrons by giving 7 ionization potentials. And already we know first ionization energy is greater than lesser than second ionization energy. As the number of electrons are moving, they are very much close to the nucleus. So the outer electrons are under the nucleus attraction. So due to which more ionization energy is required. So definitely when compared to first, second ionization energy is having more ionization energy. Then second, when compared to second, third is having more, and fourth is having more than third, and fifth is having more than fourth, vice like that it goes on. But here, how to identify whether it belongs to which group? So if you see, the first ionization is 940, second ionization is 2080, third ionization is 3090, fourth is 4140, fifth is 7030, sixth is 7870. So till here they are just comparable. Comparable in the sense they are just having 1000 or 1500 difference. Whereas if you take from 6 to 7, it is 16,000. 16,000 means definitely after removing 6 electrons, the 7th electron should be from octet configuration. Then only it is having highest ionization energy. So that element is having up to 6 valence electrons only, because 6 valence electrons, because seventh one is the seventh one, because you see 940 is first, second is 2080, third one is 3090, fourth one is 4140, fifth one is 7030, sixth one is 7870. After removing 6 electrons, the seventh one should be removing from high octet configuration. Means what? It has 6 valence electrons, because after removing all the valence electrons, next electron will have more ionization energy. So the main conclusion for this question is it has 6 valence electrons. If an element has 6 valence electrons, it is placed in 16th group. So answer is third option. So this type of questions is very important. They will give here no formula is there, nothing is there, just only concept based question. they will give initial energy values of same element for first, second, third, fourth, and so on. So if you could see, first, second, third, and fourth, if they are comparable, means there is no much difference between first, second, third, and fourth, and fifth one is very huge difference, almost double. Then we can say more than double or almost double. We can say it has only 4 valence electrons. Which one is having the biggest one? That should be definitely taken from octet configuration. So that is our main objective. So the for removing seventh electron in this case, it is requiring 16,000 kilojoules per mole, whereas for removing sixth electron is getting only 7,870. So it has only 6 valence electrons. So if an element has 6 valence electrons, its group number is 16. I hope it is clear now. Next question. Choose the true statement, the correct statement. Choose the correct statement about electronegativity and electron affinity. Choose the correct statement about electronegativity and electron affinity. First option, both represent same quantity. Both represent the same quantity. Second option, EA is a characteristic of single atom. EA, that is electron affinity, is a characteristic of single atom. Whereas EN, that is electronegativity, EA is a characteristic of single atom, whereas, continuation, same option, continuation, whereas En is the characteristic of bonded atom. E is a characteristic of bonded atom. Third option, EA is always less than En. EA is less than En. Is always less than En. Fourth option, both of them release or absorb energies. Both of them release or absorb energies. So if you take EA is less than En, both of them release absorb energies and both appear in the same quantity, and EA is that is electron affinity. What is electron affinity? The amount of energy released or absorbed, usually it is released, the amount of energy is released when a neutral gas atom gains electron. So neutral gas atom is a characteristic of single atom. So electron affinity is a characteristic of single atom, whereas electronegativity is, what is electron? The tendency of an atom to gain an electron, to accept the shared pair of electrons. Shared pair of electrons means what? It is already bonded atom. So answer will be second option. Electron affinity is the characteristic of single atom, whereas electronegativity is a characteristic of bonded atom. So answer is second option. I hope it is clear now. Second option. Remaining all it is wrong. So the correct statement is second option. Next question. Which of the following is true? Which of the following? Which of the following is true? First option, van der Waals radius greater than metallic radius greater than covalent radius. Van der Waals radius greater than metallic radius greater than covalent radius. Second option, metallic radius greater than van der Waals radius. Metallic radius greater than van der Waals radius. Van der Waals radius. Third option, covalent radius is greater than van der Waals radius. And fourth option, covalent radius greater than metallic radius. Covalent radius greater than metallic radius. So the first option is correct. Already we know van der Waals radius is greater than metallic radius and covalent radius. First option. First option is correct. Next. So van der Waals radius is always greater than covalent radius, and metallic radius is also greater than van der Waals radius is greater than metallic radius. Next question. Electronegativity of an element depends upon. Electronegativity of an element depends upon option 1, option 1. So there is nothing but factors affecting electronegativity. Easily can say first option, oxygen state of the element, oxidation state of the atom, oxygen state of the atom, state of the atom. Second option, nature of hybrid orbitals involved, nature of hybrid orbitals involved, nature of hybrid orbitals involved. Third option, effective nuclear charge, effective nuclear charge. And fourth option, all the above. And fourth option, all the above. So in the factors affecting, while we are studying in lecture 2 or lecture 3, the factors affecting electronegativity, you can able to see that slide clearly. So it is nothing but depends upon the electronegativity, depends upon oxygen state of the atom and the nature of hybrid orbitals involved. That is S is greater than P is greater than B is greater than F, and effective nuclear charge. So answer is all the above. Answer is all the above. So now I'm writing the summary of the chapter. Summary of the chapter. In summary of chapter, in this chapter, what we have learned, just only 2 topics mainly. Summary of the chapter. Summary of the chapter, we have learned. I'm writing that summary of the chapter. Chapter C. Yes. So first topic, what you have studied, we have studied classification of elements. Classification of elements. Only 2 topics in this chapter. One is first one, classification of elements. We have so many classifications. That is what you say, first Dobonier's triad, next is Mendeleev's periodic table, next is Newland's law of octaves, Lothar-Meyer curve. So this is about classification of elements and modern periodic table finally. Next, second, we have periodic properties of elements. Second, we have periodic properties of elements. And as we see the number of questions we have done based on periodic properties of elements. So answer more and more questions based on periodic properties of elements. Very, very important. So from second topic only you will get question for objective. First topic you may or may not get, but second topic is more very, very important. So second topic, periodic properties of elements, is most important, and we have to work out more questions. So that's why some questions, and mainly that is periodic properties. What are the periodic properties we have? Electronegativity, electronegativity, atomic radius, ionic radius, valency, diagonal relationship, all these are coming under periodic properties. So from periodic properties only we are going to get questions, as we have done some questions based on periodic properties because they have been giving every year. So it's very important. So you work out more. Suppose you work 10 to 20 questions from first topic, that is classification of elements, whereas at least 50 to 100 questions you have to work out on periodic properties. Anyway, we are sending the assignment. You can do that assignment clearly. I hope this is clear. So with this lecture, total 4 lectures, we have finished periodic classification of elements. So listen to all the 4 lectures properly and try to follow what we said. And you just note down the notes, classwork also, very, very important. I hope it is clear. Thank you all.